All right, now we're going to be looking at the conic section, the ellipse. An ellipse is a closed, smooth curve which is symmetrical about the horizontal and vertical axis. Now we can shift the ellipse off of the origin and it will still be symmetrical about its minor and major axis. So here's the formal definition of an ellipse. It's the set of all points P in a plane such that the sum of the distances from all of these points to two fixed points F1 and F2, which are our foci, is always a given constant. So if we take the distance from one focus to a point P and the distance from the other focus to a point P and we add those distances together, it remains constant as we move around the ellipse. From the definition of an ellipse, you can see that now we have two foci. Now the foci will always be located on the major axis. And just like with the parabola, the foci are also right next to our vertices. Now an ellipse also has two vertices. Now on the minor axis, we're going to have our co-vertices. Depending on the orientation of our ellipse, the equation of the ellipse will change, as well as the location of the vertices and foci and co-vertices. Now for a horizontal ellipse, that means our major axis is actually on the x-axis, so our vertex as well as our foci will be located there. Now as you can see, the distance from the center to the vertex is A, and the center to the co-vertice is B. So when we're looking at the equation, underneath the x we find a squared, and underneath the y squared we find b squared. For a vertical ellipse, our major axis is now the y-axis, which means our vertex and our foci are located on the y-axis. Now the distance between the center to the vertice is still a, but if you look at the equation, now a squared is located underneath y squared. And the distance between our center and our co-vertice is b, but that is now located underneath the x squared term. The focus of an ellipse is an important part of the definition of an ellipse, but is also used very often in real-world applications. In a parabola, the center of the parabola, or where all of the symmetry starts, is called the vertex. But for an ellipse, the center is called the center. So the distance between the center and the foci is still c. So the distance between the center and one of the foci is still called c. Now in order to find c for an ellipse, we have a Pythagorean relation. So if I create a right triangle using the distance between the center and one of the co-vertices, and then the distance between the center and a foci, I get this right triangle. Now the hypotenuse here we call a. So the distance of this hypotenuse is actually the same distance from the center to the vertice. So this is a and this is also a. Now applying the Pythagorean theorem, we actually get b squared plus c squared equals a squared. Now we want to find the focus, which means we need to solve for c. So for an ellipse, we actually get c squared equals a squared minus b squared. Now don't let this confuse you for our normal a, b, and c for the Pythagorean theorem. So we want to write the equation in standard form of an ellipse that has a vertex at 0, -6, and a co-vertex at 3, 0. Because my vertex is located on the y-axis, that means it's going to be a vertical ellipse, and A is going to be 6, and B is going to be 3. So remember, A is always your vertice, and B is always your co-vertice. Now we know we're going to be centered at the origin since I'm located on the y-axis. So whenever I look at my equation here, I know I'm just going to have y squared and x squared. And remember, an ellipse is always separated by a plus sign. Underneath the y squared term is always our a squared term, and x squared is always our b squared term for a vertical ellipse. And in standard form, it's always equal to 1. So I already know my value of a, it's 6, so a squared is going to be 36. My value of b is 3, so b squared is going to be 9, and that's all going to be equal to 1. So this will be my equation of this ellipse. Now remember, addition is commutative, which means I can switch these guys and I will still have the same equation. I know it's a vertical ellipse because the bigger number a is underneath the y squared term. To write the equation of an ellipse only given the foci and the covertices, you need to find where the vertex is located. So we need to find our a value. So right now we're given our foci, which is our c value, and our covertices, which is our b value. So c is going to be equal to 7 and b is going to be equal to 6. Because our foci is located on the x-axis, I know that I have a horizontal ellipse and our center is actually 0, 0. Now we need to find a. In order to find a, we need to use our Pythagorean relation, which is c squared equals a squared minus b squared. So 7 squared equals a squared minus 6 squared. Solving for a squared, we are going to get a squared is equal to 85. Because this is a horizontal ellipse, I know that my a value, my a squared value, will go underneath the x squared. It's always a plus sign for an ellipse. And then our b squared value goes underneath the minor axis, which is our y-axis, and it's always equal to 1. Now we want to find the standard equation of an ellipse with the given information. Now I'm given both vertices and one focus. So let's go ahead and sketch this information. Given this information, we can tell that we are going to have a vertical ellipse. So our a squared term will go underneath our y term in our equation. We can also tell that we have been shifted off of the origin, so our center is not going to be 0, 0. So we need to find our center in order to write the equation. So given our vertices at these coordinates, the distance between these 2 points is 10. So our center will be located halfway, which is 5 units. So either counting down 5 or counting up 5, we're going to get our center at 111. So the distance between our center and one of our vertices is 5, which means A is going to be 5. We were also given a focus, so our focus is at 114. So the distance between our focus and our center is 3 units, which means C is going to be 3. So all I'm missing now, since I have my center, I just need my B value. So using our Pythagorean relations, C squared equals A squared minus B squared. 3 squared equals 5 squared minus B squared. Solving for B, I'm going to bring B over and then bring the 9 over. So B squared is going to be equal to 16. So now writing our equation, we have to do our y minus the y coordinate of our center, which is 11, squared, plus, since we have an ellipse, x minus the x coordinate of our center, 1. Now underneath the y term, I'm going to have my a squared value, so that's going to be 25. And underneath our x term, we're going to have our b squared value, which is 16. And remember, it's always equal to 1. You must have it equal to 1. Because addition is commutative, I could rewrite this with the x term first, and it would still be correct. All right, so now I want you to try these 3 problems.